Hello students, in this video we're going to talk about lesson U1A05C, which is proving angles congruent by using complementary, supplementary, or vertical angle theorems. So we're going to take a look at specifically two-column proofs here, and we're going to use 4 ideas that will help us achieve the target that I've just read. Let's take a look at what those 4 concepts are. So the first one being that if we have 2 angles that form a straight line like I have here, so if angle X and angle Y form line ABC, then angle X and angle Y is called a linear pair. So 2 angles that form a straight line is something we call a linear pair. Now, what do we know about the angle measure of a straight line? This is, again, it's a postulate. This goes without any proof. This is something that we accept as being truth, right? So we know that a straight line is 180 degrees. So therefore, we can say that linear pairs are supplementary. We can say that angle X and angle Y will equal to, when added together, will equal to 180. These 2 ideas are going to be paired together in the various proofs that we are going to go through in this lesson and in subsequent lessons. However, just like with previous lessons, I've made some edits. So in past years, I've actually had students declare certain angles to be linear pairs before they can say that linear pairs are supplementary. So I find that to be a little bit inefficient. So in the lesson moving forward, okay, we are going to actually pair these 2 concepts together as one idea. Okay, and you're going to see what I mean by this in a moment. The third idea is supplements of congruent angles are congruent. This is the first theorem that we are going to be utilizing this year. So why is this a theorem? Well, that's because this logical statement, though for some of us who are really, really good in algebra and good with logical thinking skills, right, this seems perfectly logical. For a lot of us, including myself, actually, as a student, I remember I had to convince myself like why this is the case. So I want to take a moment, 30 seconds here, to prove to you why this is true. This is our first theorem. So since I know that a plus b is equal to 180, and I know that a plus c is equal to 180, I can therefore say, I'm going to use a pen here, that angle A plus angle, so angle A plus angle B will therefore equal to angle A plus angle C, because both of those statements equal to 180, so therefore I can make a substitution, right? I also know that angle A is equal to itself. So because angle A is equal to itself, and I linked the 2 statements together as I've written in that first step, I can then subtract the 2 statements, and what I will end up with is angle B is equal to angle C, or I can say angle B is congruent to angle C. This is the proof of this theorem. And the theorem is called, again, supplements of congruent angles are congruent. The use of this theorem will help save 3-4 different steps in the 2-column proof that we're about to do. All right, and then there's one other postulate, one other idea, and that is vertical angles are congruent. So we know that when 2 lines intersect, there will be 4 angles that are formed. The angles that are opposite of one another are going to be congruent. The angles that are adjacent to one another are going to be linear pairs. So I know that angle A will be congruent to angle B, and I know that angle C will be congruent to angle D. Angles A and C are linear pairs. A and D are linear pairs. Angle B and C are also linear pairs, and angle B and D are also linear pairs. All right, so enough about the things that we're going to be using, the tools that we're going to be using. Let's actually go through and apply some of these concepts. So take a moment and draw the diagram for yourself. Let's write down the givens and place the givens inside of a 2-column proof like I have here. And once you've done that, then press play one more time. So hopefully you guys had some time to think about this and to go through this, convincing yourself why the concluding statement there is true. But let's mark up the diagram here as a standard of practice. I know that I'm trying to prove that E is congruent to C, but I'm given that A is congruent to B here. A is congruent to G. I immediately recognize that A must be congruent to C, and E must be congruent to G. So if A has one tick mark, C therefore has one tick mark. If G has one tick mark, E therefore must have one tick mark as well. So this is true. A is congruent to C and E is congruent to G is true because those are vertical angles. So line 3, what I can say is angle E is congruent to angle G because of vertical angles. And I can also say that angle A is congruent to angle C because of, again, very similar reasons, because of vertical angles are congruent. So I want to take my highlighter now, and we are going to try to link this stuff together, right? So I know that A is congruent to C, and I know that E is congruent to G, and A is congruent to G. I can take lines 2 and 3. Actually, I don't want to highlight everything. So since I know that G is congruent to E, I can then link those two things together. I can say A is congruent to E. And this is because of substitution between lines 2 and 3. And lastly, remember, our goal is to show that A is congruent to C, right? I can then, therefore, say, since A is congruent to C, I can replace that together, right? So I can say E is therefore congruent to C. Actually, if you think about this, I mixed up the order. My apologies for that. So what I meant to say was, since A is congruent to E and A is congruent to C, I can replace A with E, like so. There you go. That makes more sense. And then because of that, I can then say E is congruent to C in step 6. And why is that? Because I'm substituting lines 4 and 5 together. All right, let's take a look at another problem. Pause the video for a moment and draw the diagram for yourself, and write down the givens in the 2-column chart like I have here. Mark up the diagram and see if you can approach this on your own. Hopefully you guys had some time to think about this. Let's take a look at what we can do to solve this now. Our goal is to show that E is congruent to D, but we're also given that A is congruent to E, so I'm going to mark that up. A and E are congruent. Excellent. We're trying to prove that E and D are congruent. So since I know that A and D are congruent because of vertical angles, and if A has one tick mark, D therefore should have one tick mark. And then that clearly illustrates why E is going to be congruent to D. Next, we're trying to prove that C is congruent to F. So I know that C and A are linear pairs, and A and C together, I'm going to use a different color now. A and C must add up to 180. E and F must also add up to 180. Since A and E are congruent from the givens, we can then therefore conclude that C and F must be congruent because supplements of congruent angles are congruent. If that logic was a little too fast for you, right? Let's go through it in detail a little to slow it down, to break it down a little more. Otherwise, you should pause and look over again to hear it one more time. Why is it that C and F must be congruent? Okay, but let's take a look. So I know that A is congruent to D because of vertical angles are congruent. And since I know that A is congruent to E and A is congruent to E and A is congruent to D, I can then replace A with E. Right? So the next statement is that E is congruent to D because I'm substituting 2 into 3. I should have written there 2 into 3. So L2 to L3. All right, so since E is congruent to D, we just proved that first question, right? The first part of that question. Next, we're trying to prove that E and F are going to be congruent. So I established, or I had used, supplemental congruent angles are congruent, right? So in order for us to use that, we need to first establish which angles are going to be supplementary to one another. And I know that angle C and D are going to be supplementary because linear pairs are supplementary. I also know that E and F are going to be supplementary because, again, linear pairs are supplementary. If you're wondering why I skipped lines 5 and 6, that's because in line 5 and line 6 I had declared C and D to be linear pairs as well as E and F to be linear pairs. And I've said in the beginning of the video that I'm not going to require you to declare that, that you can just merge those two concepts together. So C and D must be supplementary and E and F must be supplementary because linear pairs are supplementary. Since we know from line 4, that those two angles are congruent, so E and D are congruent, angle C and angle F, therefore, must be congruent as well. Why again? Because if E and D are the same, we can then say C and F are going to be congruent because supplements of congruent angles are congruent. If that is confusing to you, I recommend that you replace angle D or angle E, right, with one or the with the other. So replace angle D with angle E, right, as line number 9. Make a substitution, and then go through the algebra to show that C is congruent to F by performing a subtraction. You're going to see that you're going to reach the same conclusion. The difference is, by me using this theorem, I can save 2-3 steps. Okay? All right.